I'll start with the discussion on the Open RAN benefits. Okay, first is the diversified vendor ecosystem. Okay, so yeah, so this will remove the vendor lock-in. So this is the one. This is the one of the priority of the operator. So to remove the vendor locked-in, so they will not be confined only in one vendor as happening today in the telecom industry. So doing this will have a more competitive supplier environment. So you will have more choices and then more innovations in the industry. And at the same time, you will also have faster network deployments due to the automation and centralized radio architecture. So since the radios and the system itself are now virtualized, so you will have more time or faster network deployment. And then next is more competitive supplier environment. Okay, so if you have a more competitive supplier environment, as I mentioned, you will have more choices for vendors to be used in your network. So this is a common problem actually in one of the operators that sometimes they feel that they don't have any more choice because it's difficult for them to change their vendor because it will take a lot of money, time, and effort. And then next is the faster network deployment. Okay. As I mentioned already, because of the automation and the centralized radio architecture. Next is easy access to third-party software developers. So this come handy. For example, there is a better software or a better application that the other vendors are offering. So the operators are not anymore locked in to their current vendor, so they have the opportunity to access those third party and integrate it to their system. And of course, automation. Okay, so since this is using the continuous integration and continuous deployment, including the virtualization and programmability of the system, automation is more easy to or easier to be done in the network. And of course, the application of artificial intelligence slash machine learning. Okay, so this will help the automation as well to support the automation and also monitoring, performance improvement of the network. So currently, this is being done by engineers and some softwares like the self-optimizing network. But we believe that in this era of big data, especially in telecom, artificial intelligence is or machine learning is now a necessity to help us handle this big data, especially in telecom. And of course, there's a lower total cost of ownership, as mentioned by Engineer JM. So in terms of the total cost of ownership, so this includes the capex. Capex means capital expenditure, and also opex or operational expenses. In the recent deployment of Rakuten in Japan, they mentioned that their capex has lessened by around 30%, and the opex by 40%. So that's a big chunk of money in terms of savings. And when you look at the calculation, sample calculation, I'm creating a sample calculation for this simple so that you can appreciate what's the meaning of TCO and why operators are very concerned about the cost of installation and deployment of a telecom system. Because as you know, there's still, although we have a lot of sites already in the Philippines, but there are areas. If you already joined in the yesterday session in the executive learning series, there are also towns in Bohol, particularly in Danao, that's still not yet fully covered. So there's an option to deploy another additional cell site to have more coverage and additional capacity, but there's still restrictions, no? So one of the restrictions probably is on the business case. So especially when operators are building sites, they are calculating the what we so called the PP or the payback period. So the payback period, this is the time where you can. This is the measurement of how much time do you need to recover the initial investment. So bawi lang, no? Parang quits ba yan? Quits. Which ba? Quits, no? So we measure it using the PP. So I have created a sample calculation so that you can appreciate. Is it okay if you will see the calculation? Can I get um can you raise your hand if you want to see the calculation? Because if you don't want to see it, it's okay. Okay. All right. So one of the benefits, right, is to lower the total cost of ownership. So meaning you need to reduce the capex or reduce the opex, and at the same time increase the revenue. So this is a typical example of a calculation. So this is simplified. Why is like that? Okay. So this is a simplified formula, no? Okay. So the PP means payback. Can you see the screen?
Yes, sir. Visible.
So PP is the payback period. So this is the amount of time needed by operator to recover the initial investment. And then CapEx means the capital expenditure. So this is the total amount of money they spent in building that cell site. That includes the equipment, the baseband, the radio, the tower, the power supply, the software, the services, what else? Yeah, so basically that's it, no? Hardware, software, and services to make it simpler. And then you have the revenue. So the revenue is the amount of money that the cell site is getting from its subscriber. So it depends on how the subscriber behaves or use the cell site. If they are heavy users of data, if there's a lot of subscribers there, so it will generate more profit for the cell site or income. So we call it the revenue, and it is measured in months, no, per month. And then we have the OPEX. OPEX means operational expenses. So this is the amount or the cost that operators are using to sustain or maintain the cell site. So this includes payment of the bills, electric bills, payment for the gasoline, payment for the engineers, okay, payment for the guards. So it includes everything, rental, monthly rental. So we put it as a OPEX, okay. So now is it clear? All the definitions in the formula. Can I get
Sir Richard, the payback period is also in months, correct?
yes, sir. In
Oh,
months.
okay. So you're saying that 36 months is the good standard for payback, right?
Yes. So
Okay.
if it's in 36 months, in 3 years, you can recover your initial investment. That's a good indicator for most operators. So some operators might be stricter on this one. Okay. So it's a sample calculation. So just let's have an assumption that the one cell site cost around 200,000 US dollars. Okay. So that's just as an assumption. So that is total capex. And the OPEX per month could be 1,000 US dollars per month. So this one is the total. And this one is the monthly operational expenses. And if the revenue of the cell site is around 4,000 US dollars per month, so there are cell sites that have $10,000 per month. Some cell sites have $20,000, and some cell sites have a low revenue because there's a very low population in that area, or probably these are highway areas and the few people are using, or subscribers do not want their service. That's it. No, so there's so many reasons why the revenue is low. But if the population is low, so there's a indicator that the revenue might be low as well. Well, in some special cases, if the subscribers are heavy data users, so we can somewhat recover the revenue. If you can see here, if you have a capex like this and then an opex like this, equally for each site, and then you have a revenue of $4,000 per month, you will have a payback period of around 66 months. So it will take a lot of time. So 66 months, it's around 5.5 years. It's like buying a car or buying a mortgage car and then pay it 5 years. So it's very long for some operators. And then there are sites that earns more. Probably these are located in areas where the concentration of population or the populations are heavy users. So you can recover the capex of $2,000 in just 22.2 months. And there are sites that are very special. So these sites are really concentrated on areas like there are VIPs, there are special users that really maximize the presence of 5G, for example. So there are revenues that very high. So these are the high revenue generating sites. So as short as 10 months, we can say the capex can be recovered. Now, if the site is having a revenue per month that is lower than that's lower than the OPEX, you can see, no? You have an OPEX of $1,000 and then you have a revenue of $900 only. So you will be negative. No? You have a negative denominator, meaning the revenue you just pay you just pay the OPEX of the revenue and then you kulang ka pa, kapos pa. Yan. So it's the payback period will become negative. So if you have a negative payback period, meaning you cannot recover the investment ever because it's negative already. So if there's a special purpose of the site, maybe you can justify. But if none, that one will be going inside the eye of a needle to be approved, to be built, because the business case is not so good. Okay? Is it clear? Do you understand the simple explanation? Although when you look at the total calculation, it might be complicated because the capex will be distributed in each what do you call this, in each equipment or software. Now, if the promise of Open Run, okay, if the promise of Open Run say they will reduce it by 30%, so meaning this one will be multiplied by 0.3, 0.7, okay, 0.7, and then you will multiply it by, I don't know if this will pass, no, times 0.6, okay. So still it's still positive, no, but you can see it's still long. So there are still sites that we can further improve the PP. For example, if we put this one to here, so from 66 months, the payback period will increase to 41 months. Okay, so that's the importance of why we are concerned of lowering the total cost of ownership. The payback period might arrive earlier. Okay, so that's one of the important concerns on the total cost of ownership. That's why there are areas still in the Philippines that you can see very few population, but still we don't have any cell site build-up. So that's what we are doing in the radio network design is to maximize the coverage. we give a cost-effective solution. We call it cost-effective or cheap solution, so that the payback period will be justifiable. Okay. Okay. So how do we lower the total cost of ownership? So the number one is the use of RU, or the white box concept. So these are the general purpose processors that are easily manufactured, and that's why the reason is the cost is much cheaper. And then you have the quad server, so you don't have to buy the baseband, the complete baseband unit from a typical vendor. And then for this one, you can buy a quad server from Dell, and then you configure it with the software from another vendor. So meaning there will be some change, no, in the costing. And of course, the presence of the CI and the CD. So this is an approach of continuous integration and continuous deployment. So it will improve the approach in the testing and validation of new services and features, and will further reduce the time to market. So it will be faster to deploy to the market and reduce the time of deployment. And at the same time, the equipment and maintenance cost will be lower. Okay. Okay, so reduce time to market. So that's the effect of the lower total cost of ownership. Okay, so the reduced time to market. So these are the promises or the open run benefits that each vendor or each operator are looking at, especially if they are interested in deploying open run. Now we move on to the next topic about the open run drivers. So why do we need to deploy open run? Okay, so number one is there's a growing demand of data. Okay, based from the Global System for Mobile Communications Association, or the GSMA, the forecast between 2019 to 2025, the average amount of mobile data used by subscribers around the world will become quadruple or times 4. So in order for operators to properly deploy the capital and keep up with the growing demand for their networks, so there's a new technique that is required. So we want to serve the growing demand, but at the same time minimize the cost, right? So Open Run, which will enable the multi-vendor run solutions, provide this freedom to optimize and optimize each component of the network, while simultaneously, as I mentioned earlier, lower the total cost of ownership. Because if the cost is still high, and then there's a high demand, for operators, they will say, nag-aaksaya lang tayo ng oras. Nagpapakapagod lang tayo. Hindi naman tayo kumikita. Right? Because there's a lot of demand, but the equipment cost, the services, the software is very high. So, ang baba ng kita mo. So, hindi ka tubong lugaw. Next is the virtualization, network virtualization. So, it has been demonstrated that the disaggregation, as mentioned by Engineer JM, the disaggregation and the virtualization technologies may enable the agility while simultaneously reducing the cost. That was seen in the implementation of 4G core network in the previous years. So the development of cloud computing has made it feasible to virtualize the radio access network, or the RAN. So which gives the way to a more efficient and less expensive solution, as well as the faster innovation cycles and network administration that is fully automated. So if you're very new about the network virtualization, so let's simplify it further. So for example, you want to have a radio, you want to listen to an FM radio. So what you want to do is install the app into your Android phone or Apple phone, and then listen to your radio. And then if you don't want it anymore, just delete the app. So that's how flexible digitalization is. And then if we correlate it with virtualization, it could be the same like that. If you have an immediate demand in your network, you can configure it immediately because it's virtualized. And then if the traffic goes down, you don't need to dismantle your site. You just downgrade your capacity via remote configuration. So that's how flexible the Open RAN network will become. So it will save you operational costs for primarily. And the next, as we all know, artificial intelligence, machine learning, and big data is already on their way. So there's a fast progress made in the development of technologies, especially in this AI, ML, and the big data hints at the introduction of intelligence into the network. So currently, there are automations and self-organizing networks that installed in the network, but there are still improvements that is needed. And due to the big data that is getting in the network, so we need a more powerful and more intelligent system. So this will come the artificial intelligence. So there will be another component that will be coming inside this system. So this will come in the form of the RAN intelligent controller, or the RIC. And this RIC, the RAN intelligent controller, this is termed as the crown jewel of the Open RAN vendors. It's the cream of the crop, cream al crop, as I mentioned. So, pagalingan na lang ng AI. So, yun ang usapan niya. So, how proficient, how fast, how intelligent your RAN intelligent controller to handle your network data. That will be the main differentiator. Okay. So, these technologies, when you combine it, it will make it possible to evaluate the large amount of data that is generated in the RAN in order to foresee some potential issues and take action based on the measurement and forecasts that are made. And using this power tree, actually, you can also use for the data mining that you can see what we call the hidden traffic. So hidden traffic means these are existing subscribers that has the capacity or have the capacity to upload or download more data from the network, but currently are restricted because of their current network status. Anong ibig sabihin doon? Meaning, instead, this subscriber will watch YouTube video on his mobile device dahil 3G lang yung signal niya or 2G lang yung signal niya, he will not do it, right? Kasi mabagal, he will become frustrated. But if you overlay an LTE network or a 5G network in that area, it will trigger this need to be connected and watch videos on the YouTube. So that's what we call the hidden traffic. Okay. So we can also discover that using the artificial intelligence and machine learning and big data. And the next is the 5G use cases. So the 5G use cases, as operators move into the 5G era, so the network will go through a period of massive densification. So you will see a lot of deployment also to accommodate the use cases and that are particularly demanding. So in 5G, we have three major use cases. We have this enhanced mobile broadband, so meaning it's just faster network and higher capacity. And then you have the ultra reliable and low latency communications. This is the instant response and high reliability of the network up to 99.9999%. And of course, the massive machine type communications, or the what we so call the massive IoT. So if we have this demanding use cases, so there's still a need for a system to handle it. Okay. So if you have a lot of, for example, you have a lot of MMTC connected, no? So how can you manage those areas? So you need an artificial intelligence to do that to help you accommodate that. Okay. So these are the main drivers of the Open RAN. So there's a growing network demand, network virtualization, the artificial intelligence, machine learning, and the big data, and the 5G use cases. Well, of course, aside from the benefits and the drivers, there are also challenges in Open RAN. And as you know, as we all know, each and every one of us here have some question. Is it really that good? Right? So there are challenges, especially for this new movement in the telecom industry. First is the network performance. So there's a debate that which one has a better performance, if it's traditional or the Open RAN. So there's a common concern regarding this ability on Open RAN to match the performance of the proprietary hardware platforms. But we can see in the recent lab trials and live deployments, you can see that you can watch those trials in the ORAN Alliance. So when you go to ORAN Alliance, I'll show you the link. No? So this is the link for the ORAN Alliance. So if you will go to the ORAN Alliance, okay, so this is their website. So you just go to the Plug Fest. Okay. So when you go to the Plug Fest, you can have an idea what are the different testings and proof of concepts that they are doing. Okay. So who are the vendors involved in these trials? Okay. And then what are the results of their trials? So you can see here that the recent lab trials and live deployments that they have done addressed at the end of this of their testing are proof that Open RAN is meeting the performance objective. And if you can see also the performance of the network of the Rakuten, which is one of the largest Open RAN live network, they are at par, comparable also with the performance of other networks using the traditional network. So that answers the network performance challenge. Next is the fault management. Turuan na to, no? So when sometimes goes wrong, okay, when sometimes goes wrong in the network, isolating the component that is the source of the problem can be more complex in an Open RAN environment. So imagine from RRU to distributed unit to the CU, and then you have a different vendor. It would be a complex troubleshooting. So to solve this challenge, so the network management tools, okay, the SMO, okay, have been developed for Open RAN that is contributing to a root cause analysis and speedy issue resolution. So to identify further. And of course, it also includes the management of the Open RAN vendors. That's why one of our course here in Asia Open Academy is the management of Open RAN, because it will serve as one of the fundamentals and important skill set you need when you try to deploy an Open RAN. How to manage those vendors. Next is the automation, okay, network automation. So to fully realize the benefits of the Open RAN and to manage complexity, okay, operators must invest in the cloud management technologies. So that's why one of the courses is the cloud computing, and there's also an edge computing, okay, and the extreme automation, including orchestration and the zero touch provisioning, or the ZTP. So we will discuss that further in the next sessions in the cloud and edge computing. And of course, if there's a new movement or new philosophy of deploying telecom network, so we need to understand the Open RAN ecosystem. So this is one of the biggest enhancement to to Open RAN is the end of the vendor lockdown age, right? So we can be freed from the existing vendors. But in the new Open RAN environment, many different vendors are appearing to supply hardware and software for each element of the network. So initially, you are talking to only one or two people during the meeting. I believe every telecom engineer here can relate to what I'm saying. During the meeting, a weekly meeting with the vendors, you are only talking to one or two people. And then suddenly, if you will implement an Open RAN with three vendors, so just multiply it by three. It will be a lot. It will take a lot of your time, no? So you need to understand also the Open RAN ecosystem, okay? So you have different vendors appearing to supply the hardware, and then you have different vendors for the software, and then for each of the element of the network. And for this reason, it's important that everyone involved is aware of all the new hardware. So you have new vendors, you have new hardware, and if these hardwares are also using different softwares, so you need to be aware of that, as well as all of the providers. So for this issue, there are several initiatives that were born, no, to help companies understand and begin in this journey. That's why we are inviting here in the Asia Open Academy different vendors of Open RAN system, so that you as early as now you can be aware that what are the difference of these vendors to each other, and what are their highlights or strengths and weaknesses. And then since Open RAN is the convergence of two industries, as we mentioned here in the academy. So this is a conversion of telecom and IT. Okay. So in Open RAN, the lines between this world, the world of telecommunications and the world of IT, actually is blurred. You don't see the 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 division. No? So this implies that the roles and responsibilities defined so far within the world of mobile networks change with the arrival of Open RAN. Telecom engineers will learn virtualization. Telecom engineers will learn about artificial intelligence, machine learning, big data. Telecom engineers will learn about containerization. Okay. However, on the other side, the IT and the network engineers will learn about the RF and telecommunications, right? So because these are mixed skill set already. So for this reason, one of the challenges that companies face is adapting their teams, how to train your team, and give them the knowledge about Open RAN. So that's where the Asia Open RAN Academy comes in. We fill that gap. Okay, we help those operators or companies that would like to build their team in the Open RAN ecosystem. Okay, so we give this competency development, okay, so that their team can adapt and get a knowledge about this new way of deploying the networks. Okay, so those are the main challenges. No? So network performance, fault management, automation, understanding Open RAN ecosystem, and new team profiles. So far, saan na naka-deploy no, yung mga Open RAN system natin? So if you look at before we go for the global landscape, what are the deployment scenarios first? No? So where do we put or deploy Open RAN? Okay. If implemented well, as we always say, Open RAN technology will lower the total cost of ownership in comparison with traditional RAN. So just like, for example, what we have mentioned, a Japanese company, Rakuten in Japan, deploying an Open RAN 4G, 5G greenfield, reported a comparative reduction of 40% in CapEx and 30% in OpEx. So it's vice versa pala. So it's important to note that the TCO will vary based on the selected network architecture. So operators have the liberty to select the deployment scenarios. So one of the deployment scenarios is the coverage extension and site densification. So that's one, no? Coverage extension. So for those cell edge that you don't have much of the handover from the traditional network, you can do it. Because as a radio network designer, if you ask me, if you tell me that, okay, let's deploy an Open RAN inside Makati, I will be concerned because there will be some handover issues there because it's a different equipment inside one urban area, unless it's an IBS and we can isolate that building. But if it's an outdoor solution, there will be some concern on the island site scenario. So that we call it the island site scenario. But on the coverage extension, on the cell edge, we can have Open RAN system. And then new deployments in urban and suburban solutions, especially for the new site, for the new or the greenfield sites or greenfield operator. Okay. And if some operators would like to replace their system and do some upgrades, they can also choose Open RAN. Okay. And for rural coverage, so this one is the particular, especially for those GDAS areas, no? So those are the areas like what we have seen in Danao, Bohol, that there's a very limited coverage of cellular connection. So we can deploy Open RAN on those rural coverage, especially because if we don't have any problem in the frequency plan. If you're not using that frequency in that area and interference is not an issue anymore because it's very isolated, you can deploy Open RAN. And then support of private and neutral host networks. So this one is particularly in US, but I'm not sure if we can implement it here in the Philippines because in the US, they have a separate band. They call it the CBRS. So the CBRS, or the Citizens Broadband Radio System, it is allocated on the 3.5 gigahertz. In our country, the 3.5 gigahertz is allocated to different operator. But in the US, they allocated it for some entities to use it for private network. So if you are a private network or private company, you would like to deploy a 5G system in your factory, you can use that frequency because it's available for everybody as long as nobody is using in your area. So you can use it. So that's the private network. So you can set up your own private network using Open RAN and using that frequency. And then there's also the neutral host networks. So when you say neutral host networks, these are typical examples are a tower sharing company. So currently, tower sharing companies are providing passive solutions. When you say passive solutions, that starts from the tower itself. Okay, so you have the tower. So tower ko, no, right? If you're familiar, who's familiar in the tower ko? Familiar ba sa tower ko? So what they provide currently, you have the tower, okay? You have the power system, okay? You have the antenna system. It's all passive system, okay? So when operators might rent this space, okay, might rent this space or might rent this space, okay? So these are the neutral networks. So there's an opportunity hanging here that these neutral host networks can also explore. So meaning they can also do the active part. So when we say active part, that includes the radio, which is ORU, ORAN, and DU, which is Open RAN, open also, and the CU as well. And then if they can have this one, so it's a neutral host network that is combined with active and as well as passive. Okay, so what you're going to do here right now is like an apartment na lang. Pupunta ka na lang dyan, fully furnished na. You don't need to buy furnitures anymore. So you just rent there, rent the equipment, rent the tower, rent the antenna, rent the power supply, and then use your own frequency. That's it. You don't need to build anything. So that's one of the opportunities that we can see for the neutral host networks. Okay. And good thing here, Open RAN radios also, they can explore the multi-RAN system. So previously, what we're doing there is only one antenna and then one operator, another operator, they combine in one antenna. Now, if we go for neutral host network, if they will explore the what we call the RAN sharing solution, you have one antenna, you have one radio, okay? Two operators can use the same radio at the same time. And then they can just select if it's MORAN or the MOC-N. If it's MORAN, they will use their separate frequency. If it's MOC-N, one operator will host the other operator. So that will definitely bring down the cost of implementation. Okay, so because you're not buying any more radio. You're para kang ano na rito, para ka namang nakalimutan ko yung term, nakikisakay sa naka-carpool. Nakiki-carpool ka na diyan. Okay? Ayan, so those are the different deployment scenarios. And then if we look at the global landscape, so actually this is not so updated. This is as of June 2022. There are two ongoing Open RAN deployment. There are two communication services provider that have deployed Open RAN. One is in Rakuten in Japan, okay, and then another one in Dish in the United States. Other areas, there are still ongoing Open RAN deployments. Okay. These are the ongoing Open RAN deployments. Okay. Ayan. So ito yung status natin. Now, if you look at the Asia, here in Asia, if we zoom in right now, so you have this one, these are the different entities looking at Open RAN. Of course, Rakuten already deployed. NTT Docomo, KDDI in Japan, LGU and KT and SK Telecom, Samsung in South Korea. We have Airtel, Jio, and Vodafone in India, Axiata, Indosat in Indonesia, and National Telecom. I think it's in Malaysia. So this is the status of the deployment and trials in Japan. So we will not go further one by one. So but these are so in Japan, in South Korea, in India, Thailand. So Thailand pala yung national telecommunication. And Indonesia is Indosat. Malaysia is the IDUTCO as elaborate telecom provider to conduct testing and deployment. Axiata Group or Berhad, Group Berhad. So there's a collaboration between Mavenir and Parallel Wireless. So these are the two companies that they're working at. Okay. Now, if you look at what's available in the market, although we will be discussing this further in the Open RAN value chain, so let me just show you quickly. So what's available in the Open RAN market? If we start with the semiconductor or chipsets and component manufacturers, of course, they need to support these manufacturing of chipsets of the equipment, and including the all equipment use it for Open RAN. So you can see there's a general purpose processors, specialized chipsets, RF and analog. Intel is one of those active participants in this domain, together with Qualcomm, of course, NXP, and AMD. In the domain of ORAN hardware, so meaning those are the radios. You can see in the radios, there's a lot of names already popping up. So we have the Bicel, Comba, NEC, Mavenir, Fujitsu, CommScope, Airspan For the ODU and OCU, Dell, Hewlett-Packard, QCT. And for the full run, of course, the three major vendors are also participating. And recently we saw Nokia and Ericsson are starting to open up also their baseband unit and also the use of the open interface. For the ORAN software, you can see there's an ORAN software, the RAN intelligent controller, and the service management and orchestration. So Nokia is here, VMware is here, Ericsson, Juniper, Parallel Wireless. So you can see, some of the vendors in the IT world are also now here in the, actually they're already there a long time ago. No? It's not yet not so visible, but now, including especially in the domain of the RAN intelligent controller, you will see some familiar names. No? Yeah. Okay. Okay. And then for the cloud, so you have the cloud hardware. Okay. Of course, Dell is there. Hewlett-Packard, Lenovo. In the software domain, AWS, Red Hat, Cloud, Google Cloud, VMware, and Microsoft Azure. For the public cloud providers, AWS there, Google Cloud, Azure, Oracle, and IBM. And of course, for the services, we have the systems integration. Accenture is here, Infosys, NEC, Tech Mahindra, Hewlett-Packard, IBM, TCS. And test and measurement, you will see familiar names also. Anritsu, Rodenswartz, Keysight, of course, Viavi is here, Calnex, and Spirent. For the enterprise services, Cellnex, Nokia, Cisco services, and Ericsson. Okay, so those are what the are available now in the market. So if you're really interested in those companies and you have this skill set already, you can start searching for those opportunities there. Okay.